Okay, everyone. So if you were stuck on this problem, this is one of the more challenging balancing questions that you have for homework. This is in your workbook 51, question O. And the problem here is on one side, I've got potassium, oxygen, and hydrogen all together here. Here we've got potassium in two locations, chlorine in two locations, and oxygen in two locations, which makes balancing really tricky. Anything that I change here is going to be an issue. So when you look at this, I think chlorine probably easy to balance. And what you have to recognize here is that the oxygen, hydrogen, no matter what you do here, you're going to have the same number of oxygens, hydrogens. Doesn't matter what the coefficient is. They're always going to be an even number because they're only in this compound. So I have to make sure that the oxygen numbers have to equal hydrogen on this side. So let's look at this. So I got right now 3 oxygens and 1 here, so 4 oxygens. And here I've got only 2 hydrogens. I need more hydrogens. And you say, okay, what if I did a 2? So if I put a 2 here, I would have 4 hydrogens if I doubled up. And then I'd have 1, 2, 3, 4, 5 oxygens. It's not an even nice number. Then you say, okay, let's leave that out. What if I did the following? What if I made this a 3? And if you put a 3 here, let's see what happens. So now I'm going to have 6 of these hydrogens here, 3 oxygens and 3 oxygens. Oh, looks like we're in business here. So by doing that, we keep the number of oxygens, hydrogens proportional to each other. So this is actually good. So we're good here. So now that I've done that, let's go back to the tally chart. So on the tally chart, what I have right now, I'm going to have 2 potassiums. I've got 2 chlorines over here. I've got 6 hydrogens and 6 oxygens. So what do I do on this side? So to achieve that, I put a 6 right in front there. So now I'm going to have 6 potassium, 6 oxygens, and 6 hydrogens. So I need more potassium. I'm okay with these oxygens, hydrogens, but more potassium. So what do? You have to be careful. I don't want to mess around with this. This has 3 different elements, and they're all interconnected. So I'm going to avoid this. Let's see if we can fix this one here. So I need to have a total of 6 potassiums. What if I put a 5 in front here? And my reasoning is this. I'm only going to be changing the chlorine. If I only change the chlorine, I only have to change the coefficient here, right? If I change the chlorine and the potassium. So let's see what happens here. So I'm going to have 5 potassiums here, and 1 gives me 6. So that works out. Now the chlorines, I'm going to have 5 over here, and looks like I've got 1 over here, so 6. So I've got 6 chlorines. How do I get 6 chlorines on this side? I throw a 3 in front of there. So let's check and see what we have here. So let's double check. 6 chlorines here. I'm going to have 5, 6 chlorines here. Beautiful. We're good. Oxygens we already know are good. Hydrogens are good. How about the potassiums? I got 6, 5, and 1. There you go. And that's it for the balancing. So the key was to recognize that the oxygens and hydrogens have to be even on this side over here because we're even on that side. Hope that helps. Bye.